Hello everyone and welcome to the Victoria Engine series. This is the second episode where we will be tackling setting up on Linux. So for those of you who watched the previous version and are still using Windows, you can pretty much skip this entire video. None of this will be relevant, and I'm hoping that in the future you may still watch the videos because some of them may be relevant to how we want to set things up, and they'll make great examples for interfaces that we may be using. But for the most part, if you're using Windows, then you don't really need to watch this video. You can just skip along to the next one. But if you are using Linux, this is going to be a very important video. So there are a few prerequisites that we need before we can actually start compiling code. This tutorial may vary slightly depending on what version of Linux you use. I'm using Linux Mint. If you're using something that's an Arch-based distro, such as, well, Arch itself, then you may need to do some different instructions, but ultimately these should be more or less the same. So I'm just going to bring up a quick terminal over here, and there is one quick command you can use to install every package you need for this tutorial. So all it is I'll type it out. So if you want to install everything, all the packages we need, here's one quick command to do it. So we just need to install Clang, the libx11 and libxkb common developer drivers, and libstdc++12 for this tutorial. The reason that we do this is because when I was originally creating this video, I thought that, as I tested previously, we wouldn't need to install the libstdc++, but we need it. And libx11, I don't believe not every distro supports them natively. So you'll need to download the libraries so that you can actually use the programs themselves. But when you enter this command, I'm not going to do it. I already have these set up. You can just double check that Clang has installed, for example, by going to here and just calling Clang ++ version. And it will just tell you a bunch of version information, and this confirms more or less that Clang and Clang++ are installed. Moving swiftly from that, if we will look at our build setup, I am still using the same build that we used in the first episode, and I'll just go through a few things. So the one thing that you will need to do that I've just done here is you'll need to add a Linux section to your tasks.json so that you can call the build.sh file if you're running, of course, in Linux. I've already created that file. It's empty, but I will go through more or less every step with you. Here in the launch.json, at the moment, I currently have this error here, but I'm looking for a way to disable it. If you do find a way, please do let me know. At the moment, the only real change for that is just to change that to cppdbg, and it'll then get mad at you here, which you can just disable. You can also just completely get rid of this if you're running on Linux, just that you don't have to have all of these errors because, of course, Windows is not very good at detecting these things. So that's just sort of all the VSCode setup that you need to do there. Don't really need to explain through that. Now you want to create a build.sh file underneath the root directory, and we're going to fill it out with some things. The first thing that we need to do is we need to do !bin-bash. This just tells us that we are running this as a bash shell script. We also need to set echo to on so that we can actually call echo during the running process, and that will allow us to echo out certain things from our code. So the next thing that you'll need to do is you'll need to call make directory -p bin. What this will do is it will create a bin directory in the root folder, so you don't have to go through the process of creating your own, which is ridiculously simple, but you may need to do. And again, it should be really simple. The next thing you need to do is you need to set up our C++ files. This quick command here will just recursively find every C++ file in this directory. You'll also need to do, as you saw in the build.bat video or in the Windows setup, you also need to do the same thing for C files. I haven't explained this. I explained that in the Windows video, but I will explain it here as well. The reason that we need to, that's meant to be plural. The reason that we need to find C and C++ files in this project is because for glad, for instance, glad is a .c file, and we need to compile that C file as well as all the C++ files. So we need to get an instance of both of those. The main reason that we have a list of them rather than just directly including glad is because we may well have more than one library that we use with the project that also uses C that we also need to compile with the project. So that's the main reason we do that. And it's literally just the same thing, but just with the .c file extension rather than the .c++. So the next thing that you need to do is we need to set our current working directory. I was having issues with this, and we're just going to do it this way. pwd will just find the current working directory where this file is. We will need it for an include later, so that's just why we're writing it like that. It would be nice to just be able to call the include, but for some reason it wasn't working, so we'll just be having this sort of extra variable in the step, which shouldn't really decrease any efficiency. So next thing we need to do is we need to set our compiler flags. Just going to set those two there. Again, -g is just for debug information. -shpic is just for other help. I think it's sort of the Linux version of debug information. We don't have wall, werror here because I don't think they work. The next thing that we need is we need include flags. So our include flags or just include flag is just to include our current working directory. So the next thing that we need to set up is our linker flags. There's a bunch of these. I won't write them out this quickly, so I'll just copy and paste and you can read them as well. We basically just need to link up against all of our shared object libraries that exist across Linux, mainly our X11 and XKB libraries, as well as some other things as well, just so that everything compiles as we would hope. So here's more or less every single one of them. So we're linking against XCB, X11, X11's, XCB, XKB, common, user, X11, R6, lib, WL, RPath. That's all of those set up. Then we need to set defines. And again, the only define we're going to have enabled at this point is our debug. We will actually get around to using the debug later, but for now, it's just staying as is. And once you've done that, the only thing we need to do is just echo to build the executable. And from there, we can just call clang++ to compile our files. Okay, so now that you've done all of this, there's one more thing that we need to do before we can go ahead and test that we can build properly. And that is to type a quick command. This command here, chmod +x build.sh, that will give writing permissions to this shell script. If you don't do this manually, you'll end up with the shell script unable to write a file to your bin directory or create the bin directory in the first place, and you will end up with an invalid permissions error. So once you run this command, I've already ran it, you can then go ahead and build and it should work. So now that you've written everything there, we can now just press Ctrl+Shift+B to build, and you should see that it executes the task as it's done in my home here. It builds the executable and everything seems to have worked. Now, if you want to disable the launch option here, I've just gone to change this to cppdbg and just changed external console to false. This is just to suppress the Windows launching being completely ridiculous and flagging an error that it really shouldn't. Similarly, we have the same error here with this path. But of course, this path, as you know, doesn't exist because this is a Windows 32. Again, not the greatest things coming from the Windows side of things. But if you now hit F5, you should see that your code will run. And we have gotten our output. Of course, we're running in an internal console window rather than an external console. So, of course, we won't really be able to see the output as well as we'd like to, but hopefully that should show that everything is indeed working. So that's pretty much everything for this video. I know it's a lot shorter than the first one. That was just because we had a lot less ground to cover. Of course, again, if you did want to watch all of the code that we did in the first video, you can go check that out. Again, in the Windows part, I will leave a timestamp to the times where it's actually relevant to you if you want to, compile all this code on Windows for yourself. Or on Linux, I should say. and everything here will hopefully work. So again, thank you very, very much for watching, and I hope I will see you in episode 3, where we will start to be tackling our debugging and our logging and our error handling. But aside from that, enjoy your day, and I'll see you in the next one. A good bye.